Well, good morning, everyone, or maybe good afternoon or evening, depending where you're joining us from. Welcome here to the Launchpad and our live update coverage as NASA prepares to provide a update on their Artemis program plans. We are just a couple minutes away from the teleconference beginning, and once we do so, we will be listening in for those. But if it's your first time here, welcome. My name's Zach. I'm the founder and host here at the Launchpad, and here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together, and we're glad to have you joining us live for what will likely be a very big briefing. We are hearing some different things off the record and some rumors on what we are expecting to hear today. We are expecting to hear, quote, a multi-months delay to Artemis 2, and there are some rumblings that NASA may be actually confirming that there will be a swap between Artemis 3 and 4, and that they may actually ultimately not be landing on the surface of the moon with Artemis 2. Or Artemis 3, excuse me, but with Artemis 2. Does sound like they were getting spooled up there on the audio, so I do want to make sure that we don't miss anything here, so just give me a moment as we wait. Yeah, they're running their beautiful background music. But once they kick off the teleconference here, we will listen in for an update on the Artemis program. If you're just joining us, welcome here to the Launchpad. We are awaiting the beginning of a media teleconference with NASA. On today's teleconference, I think symbolizes how important this update is. We have Bill Nelson, the NASA Administrator, Jim Free, the NASA Associate Administrator, Catherine Koerner, the NASA Associate Administrator for Exploration Systems Development Mission Doctorate, and Amit Kshatriya, sorry if I'm saying that wrong, the NASA Deputy Associate Administrator for the Moon to Mars Program, Exploration Systems Development Mission Doctorate. So they're getting ready to begin here momentarily, and once they do, we will patch them in and listen in to their update. Take a moment, let us know in the chat where you're watching from, and we'll work on answering some of your guys' questions live while we wait. You can send those in the chat by tagging us at the Launchpad, and we will work on answering those live. Glad to have so many of you joining us here. I know a couple people are saying Artemis 2 scheduled for late November. We do have our stream scheduled for that. That's just a placeholder, but ultimately that's going to get updated here in the hopefully the next few minutes as we get an updated plan from NASA on the future of Artemis 2, possibly 3, and even 4. For those that were haven't heard the possibility of what was the idea with Artemis 3 and 4. There is a possibility that they may actually swap them, and that Artemis 4 will be the one that ultimately lands on the surface of the moon. If you're just joining us, welcome. It is now 11:30 Mountain Time, 1:30 p.m. Eastern, and we are awaiting the beginning of a media teleconference with NASA to provide an update on the future of the Artemis program. Stay with us.
call is being recorded. If anyone has any objections, you may disconnect at this time. I would now like to turn the call over to Faith Mackey. Thank you. You may begin.
Good afternoon, everyone, and thanks so much for joining us. I'm Faith Mackey with NASA's Office of Communications, and we'd like to thank you for joining this call to provide an update on the future of NASA's Artemis missions. In addition to NASA Administrator Bill Nelson, NASA participants today will include NASA Associate Administrator Jim Free, Kathy Koerner, our Associate Administrator for the Exploration Systems Development Mission Directorate at NASA, and Amit, Kshatriya, our Deputy Associate Administrator for the Moon to Mars program in NASA's Exploration Systems Development Mission Directorate. After brief opening comments from each of our speakers, we will gladly take your questions. The question and answer portion of today's call will include representatives from our industry partners and the European Space Agency. A full list of our partners on the line is available on our NASA Artemis blog at blogs.nasa.gov/Artemis. You can enter *1 on your phone to be entered in the question queue at any time, and the operator will open your mic when we're ready for your question, then close it afterwards. We ask that you please stick to one question and identify to whom your question is directed, as we won't have time to give each industry partner time to provide a specific update. We also ask that you focus your questions specifically to today's updates surrounding our future Artemis missions. Shortly after we conclude, you can listen to a replay of this teleconference online. And now I'll open the floor to Administrator Bill Nelson.
Hey, everybody. It was a little over a year ago that all of us watched Artemis 1 as a test flight. And it was so successful that additional tests were added in the course. It went further than any human-rated spacecraft, and it has that iconic picture that we've all seen where it's taking a selfie photograph of itself, and in the background, 40,000 miles away, is the moon, and further in the background, 270 miles away, is our planet. Many of the complex missions that will return astronauts to the moon and eventually to Mars all came out of what was this first test flight. And so we've named the Artemis 2 crew, and they are busy training for their mission around the moon that will test Orion systems to support human life in deep space. And again, we go back to the moon in a different way. We go back to the moon this time to a different part of the moon. We also go back to the moon with commercial partners and with international partners. And by the way, we are down here at Houston, and I visited with the crew several times yesterday. They were telling me that they were invited to the Oval Office. They were given 15 minutes to visit with the president, and they ended up visiting with him for an hour and a half. And I think it's illustrative of what's happening. I saw, for example, as we took the crew last night to the national championship game, and during one of the timeouts they were introduced, the place went nuts. So everybody is really excited. We're in a golden era of exploration. And this time, we are going back to the moon in order to be able to learn, to live, to create, and to invent in order that eventually we can go to Mars. And the science is going to help us unlock the secrets of the formation of our solar system, including the secrets of our own planet. We're going to, in the process, back to the moon, we're going to develop new technologies. We're going to develop new propulsion to go to Mars. So how we go is just as important as what we do. And so this is, to put it in the president's terms, this is a big deal. We've announced a new partnership with the UAE for Gateway, and that's a huge moment for the future of space exploration. And through CLIPS and crewed Artemis missions, we are showing the strength of the commercial partnerships and American innovation. We are doing something incredibly different. In the process of all this, as we remind everybody at every turn, safety is our top priority. And to give Artemis teams more time to work through the challenges with first-time developments, operations, and integration, we're going to give more time on Artemis 2 and 3. So what I want to tell you is we are adjusting our schedule to target Artemis 2 for September of 2025 and September of 2026 for Artemis 3, which will send humans for the first time to the lunar South Pole. Artemis 4 remains on track for September 2028. And though challenges are clearly ahead, our teams are making incredible progress, and you're going to hear about that shortly. Jim Free has done an extraordinary job leading NASA's Exploration Systems Development Mission Directorate over the past 2.5 years and standing up the Moon to Mars Program Office. Jim, as you know, is our new Associate Director, Associate Administrator, having replaced Bob Cabana, who had promised us a year before he retired, and we got almost 3 years out of Bob, and he is now having his retirement ceremony this weekend. And so Jim is going to hand the reins over to Kathy Koerner. And she and our program manager, Amit, they continue to make good progress. Think back to over 60 years ago when President Kennedy went about 20 miles from where we are now to Rice Stadium, and he made that famous speech, "We choose to go to the moon and do other things, not because it's easy, but because it's hard." And Artemis represents what we can accomplish as a country, as a global coalition, and what we can accomplish when we set our sights on what is hard and what has never been done before. So, Jim, over to you.
Thank you very much, sir. These early Artemis missions are what we refer to in our Moon to Mars architecture as our human lunar return segment. We're demonstrating the foundational systems, things like Orion and SLS, that we need to support the human missions on the surface and in lunar orbit. And as the administrator referenced, these programs reflect our different approach we are taking to extend human presence to the Moon and Mars than what we did previously in Apollo. The Moon may not be different, but our knowledge of the Moon and advancements in technology, industry capabilities have changed our approach to exploration, which you can see reflected in all of these programs. I'm going to let Amit talk more about the progress and challenges with the schedule leading up to Artemis 2 and 3, but I want to emphasize that safety is our number one priority. You heard it from the administrator today. You've heard it multiple times. And as we prepare to send our friends and colleagues on this mission, we're committed to launching as safely as possible, and we will launch when we're ready. We learned a great deal during Artemis 1 and continue to learn today through the production of Artemis 2, 3, 4, and all the hardware we have in flow. And we plan to put those lessons back into our future missions. And that's what flight tests are all about. As you heard leading up to Artemis 1, as we'll talk about for Artemis 2 and future missions, these are flight tests. Developing, testing, and learning and improving our knowledge is what we're doing, and ensuring that when we do fly, we'll be successful. Establishing the Moon to Mars Program Office that Amit leads has enabled us to improve our integrated approach across all the programs, and a great deal of credit goes to Amit and his team for that work. You heard the administrator talk about our crew. They are incredible, and they've been busy learning about the systems and subsystems they'll be flying, and they and other astronauts across the crew office can continue to monitor the design, production, and assembly of all the hardware, giving invaluable input from the operator perspective. That Artemis 2 crew will be the first people to set human eyes on the far side of the moon in more than a century, and I can't imagine all the pictures and recordings that they'll bring back to capture those moments, but also inform our understanding of the moon. The crew is a constant reminder for us of how important it is to remain focused on the work we need to do to ensure their safe return. This is a team effort, an international effort that involves our government, our international partners, our industrial partners, collaborating to achieve new milestones in human lunar exploration. Things that have never been accomplished before and that require us all working together. That's why we have our partners on the line with us today. We are facing challenges, both technical and just dealing with going back to the moon. But the Artemis team is solving them. And let me remind you that what we're talking about for these early Artemis missions includes the initial human landing system capability, the crude demonstration of the Starship human lander, the initial gateway capability, which includes the integrated power and propulsion element, along with our habitation and logistics output post that we call HALO, and the more powerful Block 1B configuration for SLS that can launch crew to the moon in Orion, along with cargo in a single launch. And for Artemis 3, we must be realistic there as well. We're looking at our Starship progress, the need for propellant transfer, the need for numerous landings. We're looking at our spacesuits that we're acquiring in a different manner that we've done before, and developing the new spacesuits as well. Soon we'll add unpressurized rover from a service perspective too. All of those alone are an incredibly large challenge and a really big deal. And I know that Kathy, Amit, our program managers, will continue to do everything in their power to work closely with our partners to keep all of these on track. So we need all parts of our team focused on performing as efficiently as possible and to the highest standards. And as I and others have said and will continue to say, we'll launch when we're ready. So let me turn it over to Amit to share some more of the challenges that we faced and how we're tracking those down.
Okay, thank you, Jim. Thank you, Senator, and thanks to both of you for your leadership. I have a lot to go through, so I'm going to try and get through it with enough time for questions. First thing I want to say is a huge thanks to all of our stakeholders and all of our industry partners, international partners that have contributed to the formulation of the Moon to Mars Program Office. The integration efforts that have been put in place by all of them have been tremendous. We really are one team, and I think you'll see that in the responses and also as we go forward. We're one team solving these problems together. We have a really complex flight test campaign that makes up these early missions. As Jim and Senator Nelson had said very clearly, and it's worth to me to say over and over again, our number one priority is safety. Our number two priority is to make sure we're making comprehensive, methodical progress towards our objective. And our number three priority is to learn from the data we get from our flight test. And I think you'll see that as we're going through, we are making that learning, and it's impacted the way we're planning these missions. And I want to talk everybody through that. So for Artemis 2, again, the primary there's new capability that's being on ramp for the mission. We have new facilities at KSC to enable rapid turnaround for propellant loading, also for the loading of the crew, for the egress of the crew. For the launch vehicle, we have a new abort system that will be activated in an integrated way across the stack. And of course, for the spacecraft, we have a new life support system and its ability to respond to those aborts. And those are all added there, of course, to support the crew and of course to support crew safety. We have two major sources of learning that are informing the way we're developing the Artemis II mission. The first, of course, is from the tremendous amount of data, the engineering data we got from the Artemis I test flight. And the second is from the production, both the components and the assembly level production that's coming in for the subsequent missions for Artemis II and III and beyond. We have hardware inflow coming in for all of those missions. We're not doing these serially. We're doing a concurrent development for a lot of this work. And so from the test flight in particular, we had one major finding that we need a little bit more time to work, and that is the performance of the thermal protection system on the spacecraft, on the heat shield. We have the heat shield itself and the Orion, the performance specification that we levied on the vehicle and on that system was met with extreme precision. We had a large factor of safety at the bond line of the spacecraft, and the entry guidance performed almost perfectly. We were able to put the vehicle right on top of our partners in the Navy, who were able to recover the vehicle very crisply. But what we did see in the performance of the heat shield itself was some unexpected phenomena that we need to make sure we understand perfectly. The lessons of our history is that even though we believe we understand and that our hardware is performing according to requirements, we have to be absolutely certain that we understand the integrated performance of that system when there are excursions from that performance. What we saw on the heat shield was, again, like I said, very good performance from a thermal protection standpoint. We did see the off-nominal recession of some char that came off the heat shield, which we were not expecting. Now, this heat shield is an ablated material. It is supposed to char, but what we were not expecting were some pieces of that char to be liberated from the vehicle, and so we need to make sure we understand the transport and debris transport phenomena that caused that. We have spent the bulk of 2023 investigating that in facilities across the agency, as well as with help from the DoD. We have an extensive investigation into the root cause of that issue, and it's going very, very well. We have great support from all our industry partners as well as our partners across the government. We have taken on a methodical, detailed campaign to understand this issue, extensive core sampling, testing, and data review, and all of that review is again, as I said, going quite well. We have to synthesize that data and update the overall thermal, mechanical, and material models of that heat shield to make sure that before we attempt reentry from a circumlunar return mission like we'll have from Artemis II, that we're 100% confident that we understand the performance of that heat shield under those conditions. We've been able to replicate the physics, and we expect to definitively identify the root cause of this recession of the char material, hopefully here in the spring. So as I mentioned, that was a large source of learning from Artemis I. We've also learned quite a bit from the acceptance of hardware coming into the flow from subsequent missions that we're planning for. One of the major ones has to do with the life support system. During the acceptance of some components for Artemis III, we noticed a failure in some motor valve circuitry that's driving valves on the spacecraft itself. This is a common motor drive set of circuits that, after investigation, these components passed acceptance testing for Artemis II, but did not pass them for Artemis III. And so that gave us pause to stop and look at that circuit in a more detailed way. When we examined it, we recognized that there was a design flaw in that circuit. Those valve electronics affect many parts of the life support system on the spacecraft, in particular the CO2 scrubbing system. And so once we recognized that the design flaw, and once we looked at rationale for potentially using the system as is, it became very clear to us that it was unacceptable to accept that hardware, and we have to replace it in order to guarantee the safety of the crew. The way to replace that hardware, given the current configuration of the spacecraft, We're going to have to. It is the access to those components, the access to those bays is going to take us quite a bit of time to get to. Every connector that we touch as part of that replacement operation will have to be tested after we're done, and we'll have to put the vehicle through full-up functional testing afterwards, and we're committed to doing that. We know how to fix it. We just need to make sure we take the time to do it according to the workmanship standards that we expect for a human-rated vehicle. The second major finding, we have, as I mentioned before, we have, for the first time on this spacecraft, we are flying an integrated abort capability. The SLS is a extremely powerful machine, and the Orion is rated to fly in deep space. And when you design a capability for the Orion to actually separate from the spacecraft, from the launch vehicle in the event of a loss of control, that environment during separation is quite severe. We've qualified the entire Orion to survive during those environments. We have, however, as part of that qualification campaign, found a few cases where we believe there could be some deficiencies in the performance of the electrical system, in particular, some of the batteries that we need to make sure we understand how they're enduring those environments. So we're still very early in that investigation. We've not yet developed a forward path. We have multiple parallel options to fix this issue. We also have a lot of options to determine whether or not we believe those environments are accurate, and we have a lot of testing to do in front of us, but we wanted to make sure we give ourselves the time to do that. And as we mentioned before, continuing our analysis, the crew safety is going to drive our decision-making there on that subject. So those are kind of the major drivers. As I said, for the Artemis 2 delay, every single one of them has to do is either a derivative of a capability that was added for safety or a mandatory fix to make sure that the vehicle is as safe as possible for our crew. So what I will say, though, is we are making tremendous progress. Jim and the administrator have already mentioned the crew is deep into training. Every component of the mission that needs to be at Kennedy, with the exception of the core stage, which is at Michoud, is already at KSC. The core stage is actually at a point of maturity that was much further along than when we shipped it for Artemis 1. We are going to hold it there at Michoud until it's the time to ship it and to be ready for this mission. But there's a lot of work that we can do at Michoud that's a little bit easier to do there than in the transfer aisle at Kennedy. But we have the booster segments ready to stack, the upper stage ready to go, and we're finishing the validation of the mobile launcher and the rest of the capability. So I'm going to move on. The last thing I'll say about Artemis 2 is that even though we want to fly, and we want to fly as safely as we can, with the delay, we're going to take advantage of some additional capability and incorporation of lessons learned from Artemis 1, including the ability to potentially access the vehicle at the pad during the launch campaign and during potential weather events. So I'll move on to Artemis 3. For Artemis 3, we're adding several new capabilities. Of course, it's been mentioned by Jim, we're adding a human landing system with a very complex propellant transfer scheme and Earth departure scheme. We're also adding advanced spacesuits. Each one of these spacesuits is an individual spacecraft for the crew, and we're adding a docking system to Orion and new choreography amongst our launch teams for a dual launch campaign required to make sure that both Orion and the lander can get to the same point in space and to proceed with the lunar landing. So the coordination and the choreography of those ground assets, as well as in space and other communication assets, is a significant coordination challenge, and we're doing everything we can to add tests and to add capability to make sure that that's successful. There's extensive integration going on across those systems. Not one of these elements, we have all the transportation elements we've been developing, but with the suits and with the lander, that's a huge conglomeration of different development activities that have to meet together, and not any single one of them is more important than the other. We need them all to be ready and all to be successful in order for that very complicated mission to come together. So the new schedule for Artemis 3 aligns with the updated schedule for Artemis 2. It ensures that we can incorporate lessons learned from Artemis 2 into that mission, and also acknowledges the very real development challenges that have been experienced by our industry partners. As I mentioned at the beginning, we have an integrated flight test approach to this capability. So as we add each new mission, it increases complexity. We have to add tests for new systems, and this new schedule will give us the opportunity for our partners to have that additional time and make the refinements to make sure we're as successful as possible. the fall of 2026, that September 2026 timeframe, is still very aggressive, and we all need to pace our work with the same degree of urgency. And I think it's very important that, and our industry partners are 100% committed to this approach. In fact, not only are they committed, but it also is worth pointing out that some of the issues we found with the Artemis 2 components on the Orion would not have been found had we not pushed our partners to deliver hardware for Artemis 3 and 4 as we proceeded towards flight. And so all of that production is teaching us as we go. But for Artemis 3, even though that fall of 2026 timeframe is aggressive, our European partners are going to ship their service module in 3 months. We have the upper stage for the SLS already delivered. The RS-25 segments, the RS-25 engines have already been delivered. We have the booster segments already ready to go. And so we have all of this work coming together, in addition to the tremendous amount of tests that's going on at Boca Chica with SpaceX and here in Houston with Axiom. So I'll move on quickly to talk about Artemis 4 and 5. For 4, we have several new developments. As Jim mentioned, it will be our first new mission to Gateway. We know we have to launch the integrated power and propulsion element and the halo. This is the core of Gateway. It will take about 12 months for that PPE halo stack to on a long spiral trajectory head out to the NRHO orbit, where we will meet them with a crewed flight as planned in September of 2028. We had previously planned to launch the PPE and halo in October of 2025. We're now working with our industry partners at Maxar and Northrop Grumman to review the schedule for when it makes sense to launch that before Artemis 4. We believe they have a great path to get us there to support that mission, but we will be updating that schedule here as well. So we're doing what we can to make sure our partners have the time to do the development correctly and safely. Jim also mentioned that Artemis 4 will incorporate the configuration of the Block 1B on the SLS with the exploration upper stage, carrying the first Gateway module as a co-manifested payload, the incredible IHAB from ESA. And Artemis 4 will also be the first mission to host logistics delivery. We have given authority to proceed from our partners at SpaceX to develop a logistics capability to deliver cargo to the Gateway space station, and that started at the end of last year. I'll finally wrap up with Artemis 5, which to me is the end of at least what I consider our responsibility as a test program. We are bringing on a brand new landing system provider. Blue Origin has been a tremendous early partner with us. We intend to announce a provider for lunar terrain vehicle services in the coming months. We'll have new Gateway components and a logistics delivery. The administrator pointed out the exciting news of our new partners in the United Arab Emirates that are going to provide an airlock for the core components of Gateway, which after that Artemis 5 and 6 timeframe will complete the core of the Gateway space station. And also, finally, in the last few months, we've asked both of our human landing system providers, SpaceX and Blue Origin, to begin applying the work they're doing on the human-rated versions of the landing vehicles to develop a cargo variant that can land large cargo on the surface, which is a tremendous change from the way we've done lunar exploration in the past. So as you can see, we have a lot of hardware in flow. I'll save more time for questions here as we go, because I've covered a lot of ground here. But this is a long-term exploration campaign, and what that means is that we're working on all these missions essentially simultaneously. We need flexibility in our manifest, we need resilience in our manifest, and that is the commitment we have from all of our NASA programs and all of our industry partners. It is essential that we make progress on every element of the campaign in order to deliver on the success of these goals. It's also essential that we're prudent in the way we're planning for if these developments maybe have more issues, so that we're ready to respond in a flexible way to make methodical progress towards our goals. So I think that's enough for me. At this point, I would like to hand over to my new boss, Kathy Koerner, to finish us up here.
Thank you, Amit, Jim, and Senator. I want to start by thanking Jim Free for his dedication and effort in standing up the Exploration Systems Mission Directorate and the Moon to Mars Program Office. I'm honored to step into this new role and lead our exploration team. Crew safety is and will remain our #1 priority. I want to thank Amit's Moon to Mars team for the detailed work that they're doing on each of these issues and managing the integrated risks and schedule across the 6 Artemis programs. As Amit noted, Artemis is a long-term exploration campaign using astronauts to conduct science at the moon and prepare for human missions to Mars. It's important that we develop and fly our foundational systems well so that we can safely carry out these missions. Moon to Mars program teams work to identify the flight test objectives that we must demonstrate on the early Artemis missions ties directly to the agency's Moon to Mars objectives and exploration approach. It is the next level of detail in implementing our Moon to Mars architecture and will provide strategic guidance for tough decisions. Our resilient mission manifest is essential for something as complex as developing the systems and technologies for long-term exploration of the moon in a manner that prioritizes scientific discovery and benefits for humanity. While Amit and his team work on the implementation approach, our broader architecture development work also continues. This last November, we completed our second architecture concept review, where we sat down with the stakeholders across NASA to review our Moon to Mars exploration plans. This most recent review focused on identifying the foundational decisions needed for a crewed mission to Mars and adding more detail to how we break down our objectives into architectural elements for long-term lunar exploration. In the coming weeks, we will publish updated materials from this last architecture concept review, which includes updates to the agency's architecture definition document and white papers highlighting critical results from the most recent strategic analysis cycle. The architecture definition document presents the current state of NASA's human spaceflight architecture and exploration strategy and breaks down the Moon to Mars objectives into functions and use cases that can be implemented through architectural elements. It includes current partnerships, identifies gaps, and presents opportunities for future collaboration. As our administrator mentioned earlier, this past Sunday, we announced a new partnership with United Arab Emirates on the airlock for Gateway. I look forward to the future partners that will one day join us, and I'm very grateful for our existing partners, the European Space Agency, the Japan Aerospace Exploration Agency, and the Canadian Space Agency. I'm also grateful for our industry partners that have agreed to be on the call today. Whether we're partnering with other space agencies or contracting with industry and academia, we have shared exploration goals and shared responsibilities. The ambitions of long-term exploration of the Moon and Mars are bigger than any one country, space agency, or company. So when we go together for the benefit of all humanity. Artemis is different from anything humanity has embarked on before. We will discover groundbreaking science and technology as we learn to live and work and explore in a collaborative and sustained manner. I look forward to working with Amit and the team, including our academic and industry and international partners, as we collectively strive to uphold our commitments and prioritize safety and exploration. Ultimately, what we build, test, and discover at the moon will determine the human capacity to explore deep space for longer periods of time, setting NASA with our partners on a steady path for our next giant leap, sending the first astronauts to Mars.
I'd like to thank our NASA leadership for their updates. We will now begin the question and answer portion of today's call. I want to please remind you to stick to one question and identify to whom your question is directed. And if we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be entered in the queue at any time, and you can enter *2 if you'd like to be removed from the queue. And one final reminder to focus your questions specifically to today's updates surrounding future Artemis missions. So I think we have in our queue, our first question will come from Marcia Dunn from the Associated Press.
Yes, hi, probably for Mr. Free. With the extra time now, are there any thoughts of sending the Artemis 2 crew into lunar orbit a la Apollo 8 versus just a fly around? And what's the chance of shoehorning another mission in between Artemis 2 and 3 if the landing systems are not ready? Thank you.
Yeah, so no, the Artemis 2 mission profile is going to remain the same. We've set that in place for a variety of reasons. We want that 24-hour orbit around Earth to make sure we can check out the vehicle. We want that path to the moon to be captured by gravity and come back, so we build resiliency into the system and have some redundancy there to bring the crew back safely. And so no thoughts to changing Artemis 2 and 3. As we've all said, we're going to learn from these missions. We're going to learn from what happens on Artemis 2. We're planning for Artemis 3 to be that landed mission. But as we say, we're going to take every bit of safety, and we'll learn from the hardware as it's developed and as it's flown, and decide from there any changes for the overall program. But as you heard today, Artemis 3 is still a landed mission in September of 26.
Thank you. We'll take the next question from Micah Maidenberg of the Wall Street Journal.
Hi, Amit. Independent of the issues that you discussed about the Artemis 2 delay, could you give a couple of specific examples about the new timeline for Artemis 3? If you hadn't found the big drivers related to Artemis 2, would Artemis 3 still need to be pushed back, and why? Thanks.
Yeah, it's a great question. I think the answer is yes. We need more time on the landing system development and on the suit development to do that. They're making tremendous progress at Boca Chica with their test flights, but it's extremely challenging to some of the propellant transfer and other goals that they have in order to make that Earth departure sequence work for us. So yeah, that I would say that even if we could fly Artemis 2 on the time frame that we had planned originally, we would still need the extra time to fly Artemis 3 in September 26.
All right. Thank you. I'm going to move on to Gina from ABC News for our next question.
I think this is for John, but at what point in the mission did the heat shield material separate? How much was it?
I think we're going to have Amit lead on that question, and then we can have John give some follow-up.
Yeah, it's interesting. We of course the other new part about the way we did return on this vehicle was we did what we call a skip reentry, and so the majority of the liberation of the material. And when I talk about it, it makes it sound like there's big chunks coming off the vehicle. That's not correct. It was some liberation of char material that, in general, we were not expecting hardly any. We did get some, and a majority of that occurred after we pulled up from the first phase of that skip reentry. We're still piecing together that overall timeline. Of course, it's very tough based on the assets we had to identify each and every one, but we went frame by frame through every piece of video that we had from Orion and from our external assets to determine when the initiation of that char liberation began, and most of it was after we started climbing out of that the first dive into the skip.
All right, thank you. Going to move on to Bill Harwood from CBS News.
Yeah, thank you very much. Can someone address for us how many refueling flights you guys think is going to be required to get HLS from Leo to the moon? There's been everything said from people on the Hill, from flights in the teens to just 4. I don't really understand why. I mean, I realize it's variable. I mean, you're in the process of planning all this, and the numbers may change. But can someone please ballpark this for us, give us a better idea of just how challenging it is to work all this out? Thanks.
Yes, sure, Bill. It's a great question. I'd like Jessica Jensen from SpaceX to take that. She's been involved heavily in the development. What I would say is, just to start with, that SpaceX has been extremely transparent with us, and we've been sharing a lot of data with them about our own challenges in terms of cryogenic refueling. So much of this is just going to have to come from flight tests. And I think probably the reason why you're hearing different numbers is because we have a lot of different modeling and analysis iterations that are going on to do that. But the rubber is going to meet the road when we actually try and do this in orbit. But I'll hand over to Jessica to see if she's got anything else to add.
Yeah, thanks, Amit. So first of all, SpaceX is super excited and really honored to be a part of the Artemis 3 program, working with NASA, Lockheed, Axiom, and all the partners to return return astronauts back to the moon. It's just truly incredible. Prop transfer is going to be a big part of that. I think one of the things I want to clarify is propellant transfer in orbit. It sounds complex and scary, and it seems like this kind of big nebulous thing. But when you really break it down into the various pieces, we've actually achieved almost all of the complex parts already on our operational programs now. And it's just going to be piecing them together for Starship. So, for example, we've berthed or docked Dragon to the International Space Station more than 30 times. So everything we've learned from the sensors we use, the algorithms we use for, safe rendezvous, from pulling back, all of that, we're going to leverage all of that in having 2 starships docked together. Another big thing that I think can seem very intimidating is, launching missions in close proximity to each other to be able to achieve, rapid refueling. And on Falcon 9, we're able to launch missions within a few hours of each other. Pad turnarounds have gotten very short. We can even launch off the same pad within a few days of each other. So again, we're going to leverage those capabilities that we've learned onto Starship. And then the last bit is, the cryogenic propellant transfer part of it. So again, that is where we're working ground tests right now, and a lot of what we do for cryogenic propellant transfer on the ground, translating that to what we do up in space. And what's so great about this is because we'll be doing it through a flight test perspective, we'll learn on the first flight test, how much propellant is actually transferred versus what we predict. We can make changes then on the ground for the next flight and iterate, and that will actually wind up determining how many missions we need. But even if it's an extensive amount of missions, we have all the capabilities and have already proven them through other vehicles that we will be able to do what Artemis 3 needs.
Jessica, this is Bill Nelson. But the question was, how many fuel transfers?
Hi, Bill. Yes, so I will say it will roughly be 10-ish. That would be my rough guess right now, but it could be lower depending on how well the first flight tests go, or it could be a little bit higher.
All right. Thank you, Jessica. I'm going to move on to Joey Roulette from Reuters for our next question.
Hey, thanks. I wanted to follow up on Marcia's question from earlier for Jim. What would it take for NASA to decide to move that first moon landing mission off of Artemis 3 and onto Artemis 4? And just for Jessica, what is Starship's current milestone schedule, including the propellant transfer test, the landings, before it makes that moon landing? Thanks.
I'll let Jessica go first since that flows from the last question, then I'll get to yours, Joey.
Thanks.
Got it. Yes. So we are tracking for propellant transfer capability, again, these initial flight tests in 2024, and then continue the learnings into 2025. One of the other missions we have leading up to Artemis 3 that we believe is super important, again, another flight test, is an uncrewed landing to the moon. So again, using Starship to do an uncrewed landing on the moon and then ascending off the surface. Super important to, again, test that before we put people on board, since, yes, as everyone said, crew safety is paramount. So we want to ensure we do as many flight tests as we possibly can, just on the Starship vehicle in general, but also do the uncrewed landing to the moon with Starship before Artemis 3.
And to your first question, Joey, I think it's what I tried to say earlier. What are we going to learn on 2 that might make us change 3? What are we going to do from a hardware availability? If the hardware is not going to be there in a reasonable time, then maybe we need to make a change. But then, what else could possibly be out there? Some of the issues that Amit put out there, like the circuit issues, we didn't anticipate. So we'll learn from the production of other vehicles as well. 2024 is a whole bunch of development for us. Some of the spacesuit development that we have to go through, the SpaceX flights for the human lander that we have to go through, the continued build of the 2 vehicles. So we're kind of constantly looking at what is going to be there, and what's going to be ready, and what do we need to do to make sure that ultimately we minimize the risk. There's always going to be risk. It's flight test. It's landing on the surface of the moon. But what do we do to minimize that from hardware availability, hardware understanding, and hardware readiness?
All right, great. I'm going to move on to Kenneth Chang from the New York Times.
Thanks. I guess as a follow-up to the SpaceX question, when would the uncrewed test be now?
Yeah, I think we can defer Jessica for that one.
Hi, yeah, we are targeting that in 2025. So again, we'll have flight tests leading up to that. We'll be working in close coordination with NASA, but we are targeting that mission in 2025.
All right, thank you. I'm going to move on to Kristen Fisher from CNN.
Hi, thanks for taking my question. This question is also for Jessica Jensen with SpaceX. Jessica, I'm just curious if you could give us an update on the timing for Starship's third test flight, and if you can confirm if it would or would not include that refueling demonstration on that next test flight. Thank you.
Hi, so yeah, we are working towards Starship flight test number 3 right now. We have static fired the booster already. We have static fired the ship. This will not be the mission that does the on-orbit ship-to-ship propellant transfer. So this is just the next series in our iterations of increasing performance and getting to orbit. But we are working towards a tipping point demonstration, so that might be what you're talking about, where the goal is to transfer propellant from the header tank into the main tank. So it's sort of a smaller subset of learning about cryogenic propellant transfer in orbit. From a hardware readiness perspective, we are targeting to be ready in January. And then from an FAA licensing perspective, for getting the license for Flight 3, part of that is closing out the corrective actions from Flight 2. We're on track for that. We're working closely, so we're expecting that license to come in February. So it is looking like Flight 3 will occur in February of this year.
All right, thank you. We're going to move on to Alicia Sowers from Mashable.
Hi, thanks for taking my question today. This is for Amit. Just so our readers can understand, if astronauts were inside Orion during Artemis 1's descent, what could have literally happened to them, given that the heat shield's material wasn't ablating like engineers expected it to? I'm just wondering, could you be as straightforward as possible and just sort of connect those dots about what exactly those potential outcomes could be?
Yeah, the great question. If we had crew on Artemis 1, the lunar return velocities would have been essentially maximal for the missions we had planned. They would have not sensed any disturbance inside the vehicle. There would not have been any excessive heating on the structure, and the guidance would have put them exactly where the Navy needed to recover them. So there would not have been any impact or to the crew safety if we had that exact same design on Artemis 1.
All right, thank you. Now we'll take a question from Eric Berger from Ars Technica.
Yeah, hi. Thanks very much for doing this. This is probably a question for Jim, but maybe also the Senator. Can you talk a little bit about the confidence that we should have in a 2026 launch date for Artemis 3? This date has moved from 2028 to 2024 to 2025, now to 2026. And, you talk to people in the industry and they don't feel like that's really realistic given all of the work that Amit described and that you described, Jim, that we've got ahead of us. And so is this really an aspirational date? Where there's a low chance, or do you think there's a 50% chance of us hitting this date? It just kind of walk me through your confidence in that date, because it does not seem to be consistent with what I'm hearing in industry.
Yeah, thanks, Eric. Thanks for making the time to be on this. It's interesting because we have 11 people in industry on here that have signed contracts to meet those dates. So from my perspective, the people in industry are here today saying we support it. We've signed contracts to those dates on the government side based on the technical details that they've given us, that our technical teams have come forward with. It is, of course, not without risk. I mean, we're moving for crew safety. We're setting a date for 3 that we have set with our contractors based on the technical plans that they've laid out. All of those technical plans have risks to them. They have risk mitigation associated with them, off-ramping points based on what we learn as we're going through some of those tests. You heard Jessica's great description of what their plans are to get through things to support 3. We also have the spacesuit development that we're on the back end of the preliminary design review for Artemis 3. So what we found out in that review process and their supply chain setup is some of what has also influenced the date. So from what do we have for confidence? I don't think I can put a number on it. What I can tell you is we put margin in there to account for some of the risks that we plan to we anticipate seeing. We've tried to address the unknown unknowns and set a realistic plan in place. One of the discussions with the crew is they want to see a realistic plan because they feel like that gives them the best path to people working to a realistic schedule, and that's what we've tried to put in place. So confidence-wise, I can tell you we've looked at all the steps, what it takes to get there to September of 26, what it takes to get there from launching in September of 25 to launching again in September of 26. An example being what happened to the mobile launcher. We understand that better. After one, we've made engineering changes for it to withstand the launch more, so we anticipate driving down some of that. So I think I want you to walk away with is the confidence is we understand the vehicle better, we understand how it comes together better, and then we have the industry people on the phone to say that's what they've signed up to contractually, and that's what we're going to hold them accountable to.
All right, thank you. We're going to take our next question from Jeff Faust from Space News.
Hey, good afternoon. A question for Amit. Of the various factors that you mentioned that led to the change in the Artemis 2 launch date, which one is on the critical path? That is, if you have continued problems with it, it would further delay the mission. Thanks.
Good question, Jeff. At this point, we drove that September date based on the time we think it's going to take to do the replacement of the life support system electronics and the penalty testing required to do the integration on the way back out. We're hopeful that the other findings, on that are as a result of abort loads on the battery, as well as the conclusion of all the test required for the heat shield is enveloped by that work.
All right, we're going to move on to Irene Klotz from Aviation Week. Irene, are you on?
I am. Can you hear me now?
Yes.
Thanks very much. Irene Klotz with Aviation Week. One quick follow on Gina's question is, could you provide some metric of how much char material was liberated, understanding that most of it occurred after that first pull-up, like what percentage came off versus what maybe you expected to see? And for Senator Nelson, you've been very clear about your concerns about China and China's development and technological initiatives in space. And with these delays in the Artemis program, I'm wondering, first of all, if you have any concerns that China would land astronauts on the moon before the U.S. program could return astronauts on the moon, and if that would be significant at all. Thank you.
Irene, I do not have a concern that China's going to land before us. I think that China has a very aggressive plan. I think they would like to land before us because that might give them some PR coup, but the fact is that I don't think they will. I think it is true that their date that they announce keeps getting earlier, but specifically with us landing in September of 26, that will be the first landing.
Okay, and yeah, to address the first question, it's tough because it was across the geometry of the acreage of the heat shield. It was very small, localized areas. In fact, interestingly, it would be much easier for us to analyze if we had larger chunks of it and we was more kind of defined. That's what makes it such an interesting material and physics problem for us to reproduce. But we do have, we have Lockheed Martin on the call, so I'd like to see if Tanya Ladwig maybe has anything she'd like to add.
I think the only thing I'd add, Amit, was, we don't know, like you said, exactly the cause of liberation. We're having great results in the testing, and that's why we're doing the extensive ground testing to analyze the data. But there was a healthy margin remaining of that virgin AV coat. So it wasn't like there were large chunks. There was, like I said, a healthy margin remaining of that virgin nav coat. And as you said earlier, the temperature data inside the cabin remained at the expected levels. So if crew were on board, they wouldn't have been in danger. So hopefully that paints a picture of that it wasn't a very large amount at all.
Yeah, I think Tanya, the only thing I'd clarify is that we did have margin in the material, but what we're really worried about and why we're spending so much time analyzing this is that as the geometry of that acreage changes, the flow around the spacecraft changes as well. So we really want to make sure that we understand for future missions under future conditions, if that margin holds up. But yeah, that's a
correct. Yeah.
Yep.
Yeah, we just want to make sure that we understand why our modeling didn't predict it, and so that we have accurate modeling for the missions going forward.
And Irene, my answer to your question, remember what I said at the outset. We don't fly until it's ready. Safety is paramount. So whether we fly in September of 26 and land, regardless of your question about China, we don't fly until it's ready.
All right, and I think we have time for one final question. So we will go with Isam Ahmed from ASP.
Yes, thank you for taking my question. I guess one of them is for Jessica. How many total orbital tests do you think Starship needs to do prior to the lunar uncrewed landing for you to be comfortable to move to the lunar test? And one question for Amit, which was in terms of the second problem, the electrical problem. I didn't quite follow. Is the suggestion that the battery might not have had power to correctly execute the ejection procedure, the abort procedure? Thank you.
Yeah, good. Thank you for the question. I'll hand over to Jessica for the first part, but on the battery itself. What we saw in the qualification test was we subjected that battery to a full separation shock that we would expect for the spacecraft coming off of the launch vehicle in the worst possible loss of control. And in that case, we saw a loss of, in some cases, connector conductivity. So the concern would be not that the vehicle would be able to abort safely off of SLS, but that we would be able to maintain all of the power margin that we need for the vehicle to from that separation all the way through landing. So we're working through all that, but it's not about safe abort capability. It's about the full functionality of the spacecraft during that abort.
Thanks.
And then Jess, if you copied the first part of the question, you can take that one.
Yep. So yeah, for leading up to the uncrewed mission, the main thing we really need is the prop transfer capability, and there's no, minimum number of flight tests. We're going to execute as many as possible. It just helps us iterate along the way. The prop transfer flight is really the main one, because really what's been happening over the past few years is we've been building the machine to build the machine. So we've basically been building all of the infrastructure and factories to ensure that Starship, sort of right out of the gate, has a high production rate, is capable of reuse, and has a high launch rate. And basically all of that is going to help us in the prop transfer flights, the uncrewed demo, and then finally the crewed landing. So it's just really taken us a long time from sort of, we'll call it like an infrastructure and getting set up perspective to get to these first flight tests. Now that we're in flight test mode, there's no bare minimum of flights. It's just as many as we can get to help us iterate a little bit faster, but really it's prop transfer capability, then the uncrewed mission.
All right, I want to thank everyone for your questions, and I know that we had some that weren't able to be answered due to time, so we're happy to follow up with you after the teleconference.
And if you're just joining us, welcome here to the launch pad. You've been listening in as NASA provided an updated timeline to the Artemis program. Artemis 2 remaining crewed, targeting now September 2025. Artemis 3 crewed landing 2026 September, and Artemis 4 still on track for September 2028. As they wrap up their briefing here, make sure you subscribe. We'll be releasing a Artemis update here in the next probably hour or so, summarizing everything that happened during today's briefing, but a very, very interesting briefing, and I have to say, I don't think I've ever heard so many NASA representatives and industry officials challenging each other, or challenging each other to actually answer the question live on air. So very, very interesting to hear this. You know, we're going back together, and it sounds like there's maybe a little bit of stress in actually getting us back to the surface of the moon, but that's understandable. Space is hard, and going to the moon is even harder. We will be releasing that Artemis update summary video in the next hour or so make sure you subscribe to see that. Join us over on our TLP Discord, and we are deep into it. We are officially into countdown to launch of Artemis 2, 3, and 4 as we get ready to head back to the moon. That's going to do it for us from our TLP Canada studio. We hope to see you back here for another live launch coverage or briefing in the near future. But for now, from our TLP Canada studio, my name's Zach, and I'll see you next time, because space is better together. Goodbye.